Okay, so today we're going to talk about circuits, resistive circuits specifically, and series circuits. To begin to talk about this, we're going to start off on the FET website here, which you can get to as you need to, and we are going to run the circuit construction kit, and we are going to start off with the intro. When we talk about circuits, typically what we're talking about is we're talking about current running through a wire. The current is electrons. So when we're talking about current running through wire, we are talking about electrons moving. So, in order to have a circuit, we have to have some wires. Now, obviously, the wires are not going to move the electrons. Okay? So, we have built a circuit here. We have wires. They are connected together. The wires have atoms. Atoms have electrons. And the electrons could be moving, but they're not. Why are the electrons not moving? The electrons are not moving because there's nothing pushing them. This is the idea of inertia. If you have a book sitting on a table, it's not going to move. The book is just going to stay there. Okay? If you have an apple in a tree, the apple is just going to stay on the tree. So when the apple is sitting in the tree, there is the weight of the apple pulling it down. There is a tension in the stem pushing it up. And the apple is going to sit there. However, if the stem breaks, the apple will fall. Because there is a potential. The gravitational potential energy converts to kinetic energy, which moves the apple. And the basis of the circuit, we need something to push the electrons in the same way that gravity pulls the apple down. So, what we are going to do is we are going to add a battery. And the battery plays the role of the potential energy. That is why a battery is called a potential. Okay, electrical potential. So a battery has electrical potential in the same way that the earth provides gravitational potential, and as you lift an apple up or a book up, you give it gravitational potential energy. A battery stores electrical potential energy, and when that electrical potential energy is released, it moves the electrons in the same way that gravitational potential energy moves the apple. If you don't have anything to break the fall, it's going to just go splat on the ground. You're no longer going to have an apple you want. In the same way, if you just let the electrons flow, they're just going to flow, and as you can see, it's just going to be a hot mess because there's nothing to control it. The way we typically control the flow of electrons is called a resistor. A resistor is there to control the flow of electrons so that we can make it do the work we want it to do. So it allows us to control the circuit, to control the flow of electrons In the same way that putting a basket when an apple falls allows us to control the fall. So we can have an apple that we can eat instead of just an apple that we can make applesauce out of. Okay, so when we put a resistor in here, we control the flow of electrons so that we can do work. Practically speaking, a resistor can be a light bulb, it can be your phone. Basically, your phone is a battery hooked up with a wire, and the phone is an equivalent resistor that consumes the power of the battery, which is why you need to charge your battery every once in a while. Okay? So, practically speaking, it's more complicated than that, but practically speaking, we talk of resistors as things that consume power. We use a resistor to control the flow of electrons in the circuit so that we can do the work we want to do. Whether that work is brightening a room with light, or making a telephone call, or watching a video. Okay? This is a circuit. There's other components that we can put in the circuit, but that's basically it. Now, if we want to be able to control the circuit, we put in a switch. And when the switch is open, the circuit is open and electrons do not flow. When the switch is closed, the circuit is made. We call it closing the circuit, completing the circuit, and electrons are allowed to flow. The value of the resistor is in ohms. Okay? And the greater the value, basically, the slower the electrons flow. So, the lower the value, the faster the electrons flow, and if it's a 0 ohms, it's like not having a resistor there, and nothing useful happens. As you increase the resistance, the electrons slow. And we can measure the flow of electrons using a ammeter. As you can see, the current increases as the resistance decreases, and the current decreases as the resistance increases. So the word that I just used is current. And current approximately is the flow of electrons. So the more flow you have, the higher current you get. We can, in fact, have more than one resistor. And there's a couple different ways to do this. The simplest way is just to put two resistors in line with each other. So you have one resistor, you have a second resistor. And the two resistors together act essentially as one, so the battery sees one resistor. When resistors are like this, they are in series. Series means that the same current flows through them. We have a battery, which provides electrical potential. When hooked up to a circuit, that electrical potential is converted into current. The current moves. Resistors are used to control that current. The higher the resistance is, the lower the current is. And if you put two resistors together so that the same current flows through them, that is called series. Now, we are going to release you to do two experiments using this lab. The first experiment, you are going to look at the relationship between electrical potential and resistance and current. As I said, resistors are there to control the current. The second one is you're going to look at what happens when you put resistors together. Because you need to understand what happens when resistors are put together in series. Series means that the current is the same through both resistors. So, to end this, let me add one more thing. I'm very specifically using the word electrical potential because it is important that you understand that the battery has potential energy, and when we hook it in a circuit, that potential energy is moved into kinetic. You have to understand that when we hook it in a circuit, that potential energy becomes kinetic energy, which is realized as the movement of electrons, or the average flow of electrons. It's not that one electron goes all the way around the loop, but there is a drift. And at the end of the day, you get an electrical charge moving around the circuit due to the electrons drifting and influenced by the potential of the battery. Now, a lot of people, and we will be using this because it is a common shorthand, call this voltage. Voltage is in fact the units that we use to measure the electrical potential of a battery. But electrical potential is really, so most people just say voltage. Current is usually just talked about as amps. Again, amps, way we measure, it is the unit that we measure current with. Amperes is actually for the full thing. But because people tend to like shorthand, instead of current, we just say amps. Now, as physicists, we like to be very precise. We like to talk about current. We like to talk about potential energy. But when you actually see this in common usage, you're going to see voltage, you're going to see amps, and so there's a bunch of different ways to talk about it. So, you're going to have to do two activities, and then you will come back and look at what we call parallel circuits.